Welcome to GCSE practice paper number 17. This is a paper 2H or 3H, the higher calculator paper. Okay, we've got a train journey. The distance and time are given. We've got to find the average speed. So we do a division and we write down the calculation that we're going to put into the calculator, which is going to be 433.5. That's the distance, and for the time we're going to use 3 hours and 24 minutes, but I'm going to write that as 3.4 hours because every 6 minutes is 0.1 of an hour. Okay, so 24 minutes is 4/10 of an hour, and if you put that in, that gives you exactly 127.5, and that's in kilometers per hour, which is what the question required. So that's the first question done. Okay, next we have to work out the amount of money in this account after 3 years. So we're investing £50,000, okay, and that increases by 2.4% per year for 3 years. So we multiply it by 1.024 to the power of 3. Okay, and that's because if you increase something by 2.4%, you have 102.4% of it, which is 1.024 as a multiplier. And when you put that in the calculator and it asks for the answer to the nearest pound, and that gives you 53687. Okay, 53687. And that's it. Okay. Next question. Okay, now we have 5 oceans listed here with the coastline length in standard form. And we've got to write down, first of all, which is the greatest. Well, that's quite easy to see. These two are the largest because they have 10 to the power 5. And of those, it's the Pacific that's the largest. So that's a simple right or wrong answer. Okay, and now we've got to find the difference. That's a subtraction between the Atlantic Ocean and the Southern Ocean's coastline. So we just need to pick those carefully. It's that one and that one there. So what we're going to do is we're going to do a division, not a division, a subtraction. And it's a calculator question, so we just need to put carefully into the calculator 1.119. Now there's a button on the calculator that does times 10 to the power of 5. And if you're going to type it in manually, if you like, then you need to put brackets around each part. And you can do that anyway, just to be safe. Okay, 1.797 times 10 to the power 4. Okay, now when you've got those two numbers typed in with the minus sign between them, you should find that that comes to 9.393 times 10 to the 4. And it doesn't say anything about the degree of accuracy, so I would just leave it like that. Okay, and that's your 3 marks for that question on standard form. And now we go on to this question about half a circle inside a rectangle. Okay, I'm just going to put some extra information on here. That must be 6 because it's the same as the radius of the semicircle, which is half the diameter. Okay, and we've got to work out the shaded area. So we want the area of the rectangle minus the area of the semicircle. Well, the rectangle is 6 times 12, and we've got to take away the half circle. Well, the area of a circle is pi r squared, so it's a half of pi times the radius squared. Well, the radius is 6, and we put that into the calculator exactly like that, and it comes out to be 15.5 centimeters squared to 3 significant figures. Okay, so show all working out clearly. Anything you put into the calculator should be written down as well on your working. Okay, question 5 coming up, and that concerns angle reasoning, and it doesn't ask for reasons to be provided, but it does ask for working out to be shown clearly. Okay, so a lot of that working out can be on the diagram. So what I'm going to do first is I'm going to recognize that this is a regular pentagon and this is a regular hexagon. In a regular pentagon, the exterior angles are 72. That comes from 360 divided by 5. Okay, so that's angle in there is 72. That's the exterior angle of that pentagon. Okay, because you extend that line out there to get 72. This one is therefore 108. Okay, as indeed are all of the angles inside the pentagon. So this angle here is 108, and so on. Okay. Now, we also have a hexagon, and the interior angles of a hexagon are 120 because the exterior angles are 60, which comes from 360 divided by 6, and that's one of them there. Okay, we've got to find this angle x. We know 2 angles inside this quadrilateral here. If we can find this one as well, okay, I'm just going to call that angle y. I can work that out because I know that this one is also 120 here. Okay, and now I've got 3 angles around a point. So I'm going to put here a calculation that y is 360, and from that I'm taking away 120, and I'm then taking away 108. Okay, and that leaves me with 240, 140, 132. Okay, 132, which is the angle y. And if y is 132, I now know 3 angles inside this quadrilateral, so I just need that x is going to be 360 minus those 3 angles. So 360, take away 60, take away 72, and take away 132. Okay, and the angle that I have left after all of that is 96 degrees. Okay, so some of the working out's done with calculations, some of it's done on the diagram, that's fine. Okay, now we have a cylinder and a cuboid. We've got to work out the volume of the cylinder, okay, but we don't know what x is, but we're going to get that from the cuboid. So this is what we're going to do. The cuboid has, so if I put the volume of the cuboid first, so cuboid, the volume is equal to, well, it's length times width times height, 12 times 5 times x, but we also know that the volume is 270 because they give us that information in the question. So from that we can work out what x is, you see. And if you know that 12 times 5 is 60, you can see that x equals 270 over 60, and that comes to exactly 4.5, okay, or 9/2. That's what your calculator would show you initially, 9/2. Okay, so we now know what x is, which is the radius of the cylinder, and we double x to get the height. So we can now work out the volume of the cylinder. So for the cylinder, okay, I'm just going to say that the volume is going to be, well, it's pi r squared times the height, okay? So it's pi times the radius squared, okay, times the height, and the height is 2 lots of 9/2. Well, that's just 9, okay, pi r squared h. Okay, and if you put that into the calculator, that comes to 573 to the nearest whole number, okay, which is equal to 573, and that's in centimeters cubed. Okay, and your working out is clear, and your answer is there. And then we've got an independent question, part B. Turn 1 cubic meter into 1 cubic centimeter. Well, if you think of a cubic meter, it's 100 centimeters long, 100 centimeters wide, and 100 centimeters tall. If you multiply those together, you get 1 million cubic centimeters. Okay, and that's that question done. Okay, next question. This is a grouped frequency table about the numbers of students and the distances they travelled. And we're told what the mean is. Normally in these questions you're given a list of just numbers here, and you've got to work out what an estimate for the mean is. You're told what that is, and you've got one missing number here to find. So basically this is what we would have done to find the mean. We would have taken the midpoint times the frequency. Half of 2 is half of that interval 0 to 2 is 1. So I've got 1 times x, okay. Then I had 11 times 3, okay, or 3 times 11. Then I had the midpoint of this, which is 5 times 8, okay. And then I had the midpoint of this, which is 7 times 6. And finally, 9 times 5. Okay, so I added all that together, the midpoints times the frequencies. Then I would have divided all of that by the total frequency. Okay, and the total frequency is the sum of all these numbers. So they come to 30 plus x, okay, x plus 30, okay, and we know that that equals 4.25, okay, because that's given in the question. So if I just work on this equation now and just multiply both sides by x plus 30, tidy all this up, on the top line I get, when I add all of that stuff together, I get x plus, that all comes to 160, so I get x plus 160, okay, and that equals 4.25 times x plus 30. Just bringing the denominator up to the other side. Okay, and I've got to solve this for x. Well, if I just multiply out the bracket on the right, that's 4.25x, okay, plus 4.25 times 30. Okay, 4.25 times 30 is 127.5. So if I now take away, best take away x from both sides, I get 160 equals 3.25x plus 127.5. And all I need to do now is subtract the 127.5, and so I've got 160 minus 127.5, and then if I divide that by 3.25, it will give me x. Okay, and put that into the calculator. Okay, and that comes to exactly 10. And that's very reassuring because first of all, it's a nice round number, but you would expect it to be a whole number anyway. If it wasn't an integer, then you would suspect that you'd done something wrong. Okay, so that's that one done. Quite a bit of working to do there. You can't really do that any other way. You've got to just go through that process. Okay, number 8. We have here a question about cumulative frequency. Now I've put this table next to this one. It was laid out differently in the question, but basically the cumulative frequency is a running total of the frequency. So up to 5 minutes, it was a total of 8. Up to 10 minutes, it's the sum of those two, which is 23. Then we add on the 17 to get 40. Then the 28 to get 68. 33 will give us 98, 101. And finally, we add the 19 to give us 120. And usually in the question, they tell you what that should be. And indeed, it says 120 there. So we know that one's right. Okay, part B, which is over here. I'll just bring this graph across. Now we're going to bring it across to here because we've finished with that part of the table now. So here's our grid, and we've got to plot the cumulative frequency on this graph. Okay, so we use little crosses like this at the end point of the interval. Up to 5 minutes, it was 8 people. So we must plot the end point, 5, 8, and we do it with a little cross and read the scale carefully. So each little square vertically is worth 2. Okay, at 10 minutes we plot 23, okay, which is there. You should be able to plot half a square, okay, and at 15 we plot 40, that's right on there, and 68 goes at 20, so that's 70, 68 there, and we've got 101 at 25, so that's just there, and finally this one up here. Okay, now you've got a choice here. You can either join them together with a smooth curve that must visit every cross, it must go through every point, or you can do a series of straight lines. Okay, I'm going to do that because using this drawing tablet and pen, it's very difficult to draw a smooth curve touching all those crosses. So I'm doing it with a series of straight lines, which is perfectly acceptable if you prefer that. Okay, and then up to here and finally to here. This technique though with straight lines is only for cumulative frequency graphs or line graphs. Other types of graphs you have to use a smooth curve. Okay, now it says use your graph to find an estimate for the median of the times. So if there's 120 people, we want the time of the 60th person. Draw it on the graph. Don't just write the answer in, and this is your evidence or you're working out to show that you've done the question properly. And read off the number that you get down there. Well, that's 60. And that's clearly going to 17.5, 18, 18.5. So I'm just going to write 18.5 minutes in that space there. And the evidence or working is clearly shown on the graph. Okay, and in the part D, we've got to kind of do this in reverse. We've got to find the percentage of people who said they waited longer than 23 minutes. Okay, so what I'm going to do is find 23 minutes, that's 22.5, that's 23 there. Okay, put a little mark, take a line from there, okay, up to the graph. Okay, that's slightly off, but I'll just do that one again. Try and get it on the line if you can. Okay, 23 is there. Touch the graph and then take it across horizontally to there. Now, you read that off. Now, that looks to me to be 87 people. Okay, so what I'm going to do is I'm going to write down, you just got to interpret this carefully. If that's 87, then what that's telling me is that I've got 87, I'm just going to write the number there, that's 87 people who say that they, those 87 people waited less than 23 minutes. So the ones who waited longer were going to be 120 minus 87, okay, and that comes to 33 people. But the question's asking for the percentage. Okay, so I now need to turn that into a percentage. So it's 33 people out of a total of 120 who had to wait longer than 23 minutes. So if you times that by 100, that turns it into a percentage, and that gives you 33 divided by 120, okay, and that gives you 27.5%, okay, and I'm just going to put that on the answer line there. Okay, if I could just move that thing out of the way, 27.5. Okay, next question. Right, I've got some numbers A, B and C. And in fact, I've got two lots of A, B and C, and I have some information about mode, median and mean. I know the numbers are in that order because A is less than B and B is less than C. And I've got to work out the value of A, B and C. Right, well, the first thing I'm going to do is write down, I'm going to use the mean first, okay, and I'm going to write down that A plus A, or 2A if you like, plus B plus C, and if I divide all that by 4, I'm going to get the mean, which I'm told is 9, okay, just put the fraction line in there. So therefore, I know that's true, and if I multiply both sides by 4, I know that A, let's just put 2A plus B plus C must be 36. Okay, so that's the first equation, if you like, that I'm going to write down. Next, I know that the median is 8.5. Now the median, if I put the four numbers in order, okay, the median is the one that would be in the middle of these two here, okay, because there's an even number of numbers. So what I know is that the median is the mean of A and B. Okay, so from that, A plus B over 2 would have to be equal to 8.5. Okay, so A plus B over 2 is the median, which is 8.5. Therefore, A plus B must be 17. Okay, A plus B is therefore 17. And then I've got a third piece of information. The mode is 7. Well, the mode is the most common, which is A. So I now know that A is 7. Okay. If I go up to here, I can now replace that A with 7 and add B to it to get 17. And from that, I must know that B is 10. And now I know what A and B are, I can find C from this one. So two lots of A must be 14, B is 10, so 14 plus 10 is 24, and I've got to add something on to make 36, okay, and what I've got to add on is 12. So it all fits into place. Okay, next question. Number 10, on the number line, show this inequality. Right, minus 2 is less than and including y. So basically I have to fill in that blob. 1 is, it's up to but not including 1, so it's an open circle like that, and I just join them with a straight horizontal line. That's it. Write down all the values of n that satisfy this inequality, or n's got to be bigger than minus 3.4, and because it's an integer, the first integer bigger than that is minus 3. It could be minus 2, because that's in the range, or minus 1, or 0, or 1, and it can even be 2, because it includes 2. Okay, but it can't be any more than 2. That's the answer there. Next, number 11, on Wednesday the price of 1 litre of petrol was £1.26. That was an increase of 5% of what it was the previous Monday. I'm going to call that value x. So if the original price was x, okay, and I increased it by 5%, then I multiplied it by 1.05. And that gave me £1.26. That was the Wednesday price. So therefore, x must have been £1.26 divided by 1.05. Okay, and if you put that onto the calculator, that gives you exactly 1.2. Okay, meaning that the price of petrol on that Monday was £1.20. Okay, common mistake here is people try and work out 5% of £1.26, which is not the problem. The 5% applies to the x, not to the £1.26. So basically 1 litre of petrol costs £1.20, but we bought 30 of them, so 30 times £1.20, there's our working out, will give us the total cost of petrol for that filling up then, which is £36. Okay, and in this question 12, this is about functions f and g. Okay, now this is one of the sort of higher grade topics, but it's actually not always that difficult. Now, doing fg of 3 means you apply the function g to 3 first of all, and when you've got the answer to that, you apply it to f. Now, you could do it with 3, or you could do it with fg of x first, and I tend to prefer that method because that's going to be useful in part B as well. So basically, f of g of x means do a g of x and then apply an f to that. Okay, so the g of x is x minus 10. Okay, so it's x minus 10, that's the g, but what I've got to do is now apply an f to that, which is to square it and add 6. Okay, so fg of 3 just means putting in the number 3 instead of x, which is going to be 3 minus 10, okay, squared, which is minus 7 squared, which is 49, plus 6, which is 55. Okay, so that's the first part of the question. Then you have to do, that's part A. Okay, so for part B, what we now have to do is solve the equation that fg of x equals f of x. Okay, well fg of x is x minus 10 squared, and we've got to set that plus 6, and that's got to equal f of x, which is just x squared plus 6. Okay, well, if we just multiply out this bracket, so x minus 10 times x minus 10, that's using two brackets side by side, first outer inner last, will give you x squared minus two lots of 10x, so that's minus 20x plus 100. Okay, and then I've also got my plus 6, and that all equals x squared plus 6. Okay, now I can cancel out the x squareds because this is 1 on each side, and there's also a 6 on each side. So I'm left with minus 20x plus 100 equals 0. Okay, and therefore 100 equals 20x. And if 100 is 20x, then x must be 5. And that's it. So it's actually worked out quite straightforward to do that question. Question 13. We have the wall of the side of a house and we've got to paint it. 16 square meters of paint will come from one tin. How many tins do we need to paint this? Well, obviously we need to know its area first of all. So we'll just divide it into a triangle and a rectangle. Okay, we can see straight away that the area of the rectangle is 60. Okay, so I'm just going to write here 10 times 6, okay, is 60. So that's quite easy to spot straight away. Okay, now the other part of it is the roof, and I need the height of that roof really, because I have the sloping sides. So if I just put a line down there, it says it's symmetrical. This is going to be 5, okay, and this is going to be 5 as well. And using Pythagoras Theorem, I can do that the height, if I call that h of that roof part, is going to be the square root of, okay, the long side squared minus the known short side squared, okay, which is the square root of that, which comes to root 24, okay, and that's the height. That's the same as root 4 root 6, which is 2 root 6, but root 24 is fine for this calculation. So the area of the roof is a half base times height. So I've got a half of the base, which is 10, times root 24. Okay. And that is got to be added on to the 60 that I've already worked out. Okay, and if you put that into the calculator, you get 84.49. Okay, so I'm just going to put 84.49, and then it goes on after that, but it doesn't really matter because you've now got to divide that by 16, which is the amount of paint you need to cover. 16 meters squared is the amount you can cover with one tin of paint. So if I put 84.49, divide that by 16, I'm going to have to round that up, okay, because if I need more than a certain number of tins, I've just got to round up all the time. So that comes to 5.28, okay, so that's all I need, just 5.2 will do, 5.28, and therefore 6 tins are needed, 6 tins. Okay, as long as that's clear and your answer's clear, the working shows how I got it, that's done. Okay, a couple of balloons, one higher than the other, and you've got to use the information given that the angle of depression is 23 degrees. So what that means is that if you were in balloon A looking down to the basket of balloon B, you would be looking down at an angle of 23 degrees. Okay, so that angle's 23 degrees, and using alternate angles, it means if I projected a line across here to below A, that's also 23 degrees down there. Okay, and what I'm going to need to do is use the fact that the length of this dotted line here is 500 meters. This is 23 degrees. I need to know how high above the level of B, the altitude of B, is the balloon A. So what's that height there? Okay, so right angle triangle. I'm going to call this height here H, and I'm going to do some trigonometry because I know that the opposite over the hypotenuse, O over H, sorry, opposite over hypotenuse, this H is for the height. I'm referring to hypotenuse here, so that's slightly confusing, but basically H over 500 is the sine of 23 degrees. Okay, so therefore the height H is 500 times the sine of 23. Okay, make sure the calculator is set to degrees, and that will give you in meters the height, which is 195.4, because it asks for it to 1 decimal place, and that's 1 dp. Okay, so just read the question carefully. Quite often they would ask that to the nearest meter, but in this case they want it to 1 decimal place. Okay, next question. Now this is a really interesting question on upper and lower bounds, and what I'm going to do here to get all the marks for a question like this, show clearly the upper and lower bounds of each part. Okay, so for the value of t is 14 correct two significant figures, so that means that it could have come from 13.5, okay, up to 14.5. Okay, so I'm going to do a little table actually like this. This is often quicker. So there's the two numbers. It's come from those two, anywhere in that range. This is what we call the lower bound, and this is the upper bound. Okay, and this is for t. Now we'll do one for A. Again, it's been given to two significant figures, so it could have come from 7.75 up to 7.85, anywhere in that range. Okay, and for H, again, two significant figures, so it could be 3.35 up to 3.45. Okay, so what we now have to do is we've got to find the lower bound of the value of k. Now when you have a fraction and a subtraction together, that's the most difficult type of problem to deal with, because you have to get the lowest value of k. So that means that the numerator must be as small as possible. Okay, so that's this one we use, because that's on the numerator. And the gap between these two must be as large as possible because it's a subtraction. Okay, so we need to start with the largest possible A and the smallest possible H. So they're the three values that we're going to use in the equation. So I'm going to now say that K is going to be 13.5. Okay, and that has to be divided by, I need A minus H, so it's going to be 7.85. Okay, minus 3.35. Okay, and that will give us the smallest possible value of k that we could get using those limits. If you put that in the calculator, it comes to exactly 3. Exactly, and that's the answer. Question 16. Here we have a histogram, okay? And here the area of each block represents the frequency. So the first thing to do is to get the frequency density. And the frequency density is the height up the y-axis. Now, if this is 28, this first block on the left, okay, that's the frequency, and it's a width of 2. That means that this height here must represent 14, okay, because 14 times 2 is the area, 28. So the frequency density is 14. Okay, now that's all I need to work out the scale, because I can see that this is 12, okay, and this is 8, and this is 4. Okay, it all fits in nicely. This is 16, this is 20, and then I can go up to 24 there, 28, and so on. Okay, so it's very conveniently worked out. It often does. So that's 14. Now for the second bar, I can see that that goes up to 20. So it's got a frequency density of 20. 20 times 2, because that's 2 wide as well, that's 40. Okay. The next one, the third one, is 30. And it's a width of 1, so 1 times 30 is 30. This one is 24, and this one is also 24 because it's a width of 1 again. And finally, this one has a height of just 12, but a width of 3, so 12 times 3 is 36. Okay, the total frequency, if you add those numbers together, is 158. And we've got to estimate the mean time that a year 11 spends on homework. Now, basically, we have to do the midpoint times the frequency. So I've got 2, half of that interval, halfway between 0 and 2 is 1. So I've got 1 times 28. Okay, and there's quite a lot to write down here. So 1 times 28 plus, now it's 3 times 40. Okay, 3 times 40. Then I've got halfway between 4 and 5 is 4.5 times 30. Then I've got 5.5 times 24, midpoint times frequency. And then I've got 7.5 times 36. And then all of that has to be divided by the total frequency, which is 158. Okay, and you can put that on the calculator exactly like that. Okay, and that gives you 4.335, 4.335, etc. And you just need to give that to a reasonable degree of accuracy. And it says 3 significant figures actually, so make sure that you give that in that way. 4.34, and it's the amount of time they spent on homework in hours, so it's hours. Okay, you've got to be accurate with that. I mean, that will be, they're looking for 4.34. So you've got to do that working out exactly like that. Okay, this is a question about a circle and, well, it's what we call a major sector. And we've got to calculate the perimeter of the shaded sector of the circle, the perimeter. So this is called a major arc, this part round here. Okay, but we've also got these two bits here to consider. So these often get missed out. So it's the area, not the area, it's the length of these two in yellow plus the bit round the edge of the circle. Now, if this were a whole circle, it would be 2 pi r. Okay, that would be the circumference, but it's not a whole circle, it's 40 degrees less. In fact, it's 320 degrees worth of a circle. So I've got 320 360ths of a circle, which has a circumference of 2 times pi times r. So it's that times 2 times pi times the radius. Okay. And I've just got to multiply those together. And I've also got to add the two straight pieces, the radiuses, which is 2 lots of 9. Okay. So if I put all that together on the calculator, that will give me the length I require, and that comes to 68.3. Okay, 68.3 to 3 significant figures, and that's in centimeters. Okay. So clear working out and an answer shown clearly. Next, question number 18, circle theorems. Immediately you see that, and the first thing you've got to do is, well, show information on here and here. It says give reasons for your working, so you must actually give proper circle angle reasons. So I'm going to start by writing that, I'm going to start by showing the angle I need, which is the angle BDE. Okay, BDE, which is that one there. Just going to make this clear. This is B here. It's partly erased. There it is. Okay, and so it's this angle here in yellow that I'm interested in finding. Okay, so what I'm going to do first is write down that this angle here is 39. Okay, and the reason I know that that's 39 is because it's from the alternate segment theorem. Okay, so my reasoning starts now. I've got to write this down to get the marks. So angle BFD is equal to angle ABD, okay, which is equal to 39, and the reason is alternate segment theorem, and that's an acceptable reason, just like that, alternate segment theorem. Okay, so that's the first part done. Don't just write it down and leave it, because you won't get the marks. You've got to give the reasons. Then it says, okay, so that's 39. And so I'm now going to notice that I have here a quadrilateral, BDEF, all four corners touching the circle. That's called a cyclic quadrilateral. And I know that the opposite angles in a cyclic quadrilateral add to 180. So angle BFE, okay, BFE, so that's the sum of 39 and 18. So BFE is the plus my angle that I need, which is BDE, plus that equals 180. And the reason I know that's true is that opposite angles in cyclic quadrilateral. Okay, I'm abbreviating slightly here, but that should be okay. Okay, now that's how I know, that's the reason. So what is the actual value? Well, BFE is going to be, so from that information I can say that angle BDE, okay, is equal to 180 minus the two angles that make up BFE, which is 18 and 39. Okay, so if I add those two together and take them away from 180, I get 123 degrees. Okay, but to get the marks, I think there are 4 or 5 marks for that question. You've got to have those reasons clearly shown. Okay. Number 19, Simon bought a house at the beginning of 2018. Now, you read through this question carefully. There's quite a lot to do here. I'm going to start by saying that in the beginning of 2018, the house was worth X amount, right? So I'm just going to say it was worth X at that point, right? Now, I'm going to take a sort of timeline here. So I'm going to take X and I'm going to multiply it by 0.85 because it fell by 85%, okay, sorry, by 15% in that first year, all right? And then for the next 2 years, it increased by, let's say, Y% twice. Okay, that's for 2019 and 2020. So to show Y%, I'm going to write this. It's going to be 100 plus Y over 100. Okay? And if you think about that, that means that suppose Y was 5%, then that would be multiplying by 105 over 100, you see, which is 1.05. If Y was, say, 7%, it would be 107 over 100, 1.07. So that's how I've come to that conclusion. But I'm doing that for 2 years running. So I'm doing that. And I know that when I've done all of that, that the value of the house is 2.85% greater. So it's basically going to be 1.0285 times what it was originally. Okay, now immediately I can cancel the x's. I'm just going to write here the percentage increase during were the same. I'm going to call that Y%. I'm just making a note of that there. Okay, that's what Y is. So if you notice, I can divide both sides by x, and I get this equation that 0.85 times 100 plus y over 100 squared. Okay, that whole thing squared times 0.85 equals 1.0285. Okay, so I've got to find out what y is. So basically I need to divide by 0.85. So I can rewrite that and say that, well, let's save a bit of time. I can take this part of it out here. Okay, make a copy of that, put it down here. So that equals that over 0.85. Okay, so I've just divided both sides by 0.85. And now if I multiply both sides by, if I square root both sides, so I can hopefully now take this again. Let's just take another copy of that. Okay, more difficult to do that now. Take that, copy of it down there. If I now square root both sides, then I get this. Okay, and then I need to multiply both sides by 100 and subtract 100. So I can say therefore that from here that y equals this thing here. Okay, and what I'm going to do is I'm going to multiply it by 100. I'm going to put 100 in front of it, and I'm then going to subtract 100. And if you put that into the calculator, it gives you exactly 10%, exactly. Okay, which is very reassuring. It seems a nice round number. Now, what that means, just to summarize, is that the house fell by 15% in the first year. The next year it went up by 10% of that, then 10% again, and the resulting increase or change was that it was 2.85% above what it started with. Now, you'd never have guessed that from the information. You have to go through that process. Okay, and the last question. Okay, the last question. Now, this looks really difficult because you've got this sort of random triangle, this point O right in the middle of the circle, with no apparent connection to the triangle, and you've got to work out the radius of this circle. Okay, and you're told that this bit here has an area of 200, and that's all. Well, what you do, hopefully, is spot one of the circle theorems straight away, and that to there creates an angle, and that angle is twice the angle on the circumference. So if that's 75, this is 150 degrees. Okay, and that's your starting point, because what you've now got is this whole thing here, AOC, round the side, is a sector of a circle. Okay, and if I take away from that sector the area of this triangle here, it will leave me with 200. So I'm going to put sector, so the sector, okay, AOC minus the triangle AOC equals 200. That's my sort of opening statement, if you like, to show that I understand the question. Okay, so what's the sector area? Well, the sector is a fraction of a circle, so it's 150 degrees worth of a circle, and the circle is 360 degrees of the area of a circle, that's pi r squared. Okay, and we don't know what r is, so we're just going to leave it as r, because that's what we've got to find. So that's r, and that's r there as well. Okay, now the triangle has an area using, when you learnt about the sine and cosine rule, you also learnt that the area of a triangle is a half times the two sides, either side of an angle that you know. So it's a half of r times the sine of 150. Okay. So, and we know that that equals 200. Now we can factorize out r squared. So r squared, okay, is common to both of these terms. So r squared, and then we've got 150 over 360. I'm just going to simplify that. They both divide by 30 to give me 5/12. So 5/12 of pi minus, and then I've got a half of the sine of 150. Now the sine of 150 is the same as the sine of 30. If you think of the symmetry and shape of the sine graph, and the sine of 30 you should know is a half, but you've got the calculator anyway, so it's a half of r squared times a half, which is a quarter. Okay, and that equals 200. So all I need to do now is to divide both sides by this. So r squared is equal to, well, in fact, I could just go straight now to r, I think. R is equal to the square root of, now, I could make this into a nice, neat algebraic expression, but you have a calculator, and if you use it carefully, there's no reason why you couldn't just go straight into this, but just be very careful to set it up properly. It's going to be 200, okay, divided by this fraction here. Okay, so let me just do that for you. 200 over this thing here. So if I just make a quick copy of that. Okay, and put that under there. As long as that's presented on the calculator like that, it will give you the right answer. And it comes to 13.7 centimeters to 3 significant figures, which is what it asks for. Okay, now quite a difficult problem, that one, but then it is right at the end of the paper, so that's often the case. And there you have it. So an interesting question to finish with. Hope that was helpful. Take care.